I'm Anil Kumar. Welcome to my series on calculus. Let's get started with it. And before that, we should review some important concepts. Topics listed here, six of them, are very important to understand before we get into intricacies of calculus. We'll see how do we isolate variables. We'll take up completing the squares case for a quadratic equation. Then we'll understand what is explicit form of an equation. It is normally required to write equation in terms of y equals to f of x. So that is how we will be writing explicit form of equations. We should understand whether a function is even or odd, rationalize functions, domain and range of functions, and then sketch functions. So let's begin with isolating variables. So I've taken a very typical example, which is written here as minus 12 x squared plus 3x plus 10. Now from this equation, we need to isolate x, right? So we have x at two different places. You cannot simply take it common and then isolate. The strategy here, of course, is to complete the squares. So the strategy is called completing squares. We'll write this strategy here. You use this technique to find the vertex of a parabola. Now we are going to use the same technique. So minus 12 will be taken common, which is the leading coefficient. We are left with x squared. And here we have to divide by 12, so it becomes minus. 3 divided by 12 is 4, so 1 over 4x. Let's keep this 10 away, equals to 0. Now the next step is to do half of the coefficient of x, right? We have 1 over 4x. Half of 1 over 4 will be 1 over 8. So we'll add and subtract 1 over 8 square, correct? Plus 10 equals to 0. Now, first three terms will form a perfect square, right? A minus b whole square in this particular case. So we get minus 12, and we can write this as x minus 1 over 8 whole square. Now we can open this. 1 over 8 whole square is 1 over 64. 8 square is 64, right? Bracket close, plus 10 equals to 0. So let's open this bracket by multiplying by minus 12. So we get minus 12 times x minus 1 over 8 whole square. And now when you multiply 12 by 64, then you could simplify this, dividing both by, let's say, 4. So 4 times 3, minus and minus will become positive. 4 times 3, and dividing this by 4, 4 times 1 is 4, we get 16, correct? So that's what we get when you open the bracket and multiply by minus 12. Plus 10 equals to 0. Now, to isolate, let's take the constant terms to the right side. So we get minus 12 x minus 1 over 8 whole square. And that, for the time being, let me write them here only. 16 is the common denominator. 3 plus 160 equals to 0. Let's divide this page. We can now write 3 plus 160 is 163, right? So 163 divided by 16 is equal to, we can take the term minus 12 on the right side, so it becomes 12 x minus 1 over 8 whole square. Now we can divide this by 12, so we get 163 over 16 times 12 equals to x minus 1 over 8 whole square. Now we can square root this. So whenever you square root, you have to do plus and minus. So we get 163 over 16 times 12, right, equals to x minus 1 over 8. And now we get the value of x as equal to 1 over 8 plus or minus square root of 163 over 16 times 12. Is that clear to you, right? So that is how you have to isolate x when given in quadratic form, right? Standard form. So you need to complete the squares and then get. It's kind of complicated. We are taking such examples as we may sometimes need to do this exercise in calculus. Now the next example here is to explicit form of an equation. Now, explicit form is to write each equation as y equals to f of x. So y as a function of x. That is what is called explicit form of an equation. Let's see how to do it. We are given the equation which is 2xy plus y minus 3x plus 5 equals to 0. Now from the first two terms we can take y common. So we get 2x plus 1 and we have minus 3x plus 5 equals to 0. Now it is easy. We will take the other terms first to the right side, right? So that will become 3x minus 5, and now we can divide 3x minus 5 by 2x plus 1 to get the explicit form of the equation. So we have written y's on one side and x on the other side. Well, this definitely will have some restrictions, and as you know, x is not equal to minus half. Even if it is not asked for, it is kind of important to specify it. So let's take more examples on how to work with explicit forms. Here we have another equation which is x squared plus y squared plus 10x minus 4y equals to 15. Do you recall what kind of equation it is? What kind of graph can you get? Well, of course, it is a circle, right? Now, how do you isolate y in this particular case? We'll again do completing the squares. So here again, the strategy actually is completing squares. As you can see, completing squares is indeed a very important strategy. So let's collect the x terms together. First, we have x squared plus 10x, and on the y side, we have plus y squared minus 4y, and we have 15 on the other side. To complete the squares, what is half of 10? Well, half of 10 is 5, so we should add 5 square, correct? So we'll add 5 square here. So let's add 5 square on both the sides. So we'll do 5 square, which is 25. And on this side also, let's write, let me write 5 square first. Okay. So, and I'll continue writing the other terms, which is 15. Now, that will complete the squares, and we could write this as x plus 5 whole squared. You get the idea. That is why we wrote 5 here. Now it becomes a perfect square. Now similarly for y, what should I write in this case? We have y squared minus 4y. Half of 4 is 2. So we are going to write 2 square, and we are going to subtract 2 square also, right? Same operations on both the sides. Now that could be written as y minus 2 whole square equals to, we can now simplify these terms, which is 5 square is 25, adding 5 is 30, and 10 40, and 40 take away 4 is 36. So we get 36 on the right side. Now from here we can say y minus 2 whole square is indeed equal to 36 minus x plus 5 whole square, and we can say that y minus 2 is equal to square root of 36 minus x plus 5 whole square. Whenever you do square root, you have to write plus and minus. So now we get close to the explicit form. We can now write down the answer here as y is equal to 2 is positive plus and minus square root of 36 minus x plus 5 whole square. Well, you can simplify further by expanding this and then writing down a simplified form within the square root function. Perfect. But anyway, you kind of understand that this is how you could write explicit form of the equation of a circle. Perfect. Now, you can see from this stage that the circle has been defined whose center is at minus 5 and 2, right? So let me just sketch it on the side to give you an idea of what we have got into. So we have a circle whose center has been identified as minus 5, 2, right? So this is minus 5 and 2, and the radius is square root of 36, which is 6, correct? Anyway, let's take the next example. And in the next example, it is explicit form again. Write each equation as y equals to f of x, and the equation given to us is e to the power of x plus xy minus 5 equals to 1. So you can actually pause the video, solve this, and then look into my suggestions. So to get this, well, let's take 5 first to the right side. So we get e to the power of x plus xy equals to 1 plus 5, which is equal to 6. Now, when we have e, the inverse of exponential functions is log ln. So we can take log both sides. So we get ln e to the power of x plus xy, and that is equal to ln 6. Now, here, ln e is 1. So we are left with x plus xy equals to ln 6. And now we can isolate y. So we can take x to the other side and divide by x. Perfect. So let's do it on the right hand side. So I hope the steps are absolutely clear. So we get xy equals to ln 6 minus x, and y is equal to ln 6 minus x divided by x. So that is how you could write. You could also write this as ln 6, which is a constant, over x minus 1. So either way, you get the answer. Perfect. So that is how it could be written in the explicit form. Let's take another example now, which is another logarithmic function. Write each equation in the explicit form. This is the fourth example which we are doing. Ln x plus ln x plus 1 minus ln y minus 1 equals to minus 2. So that is a logarithmic equation which we need to write explicitly in terms of y equals to f of x, right? That's the idea. I'd like you to actually pause the video, complete this question, and then look into my suggestions. So there is only one term with y minus 1, right? However, we can use the laws or rules of logarithms, right? So let's say rules of logarithms, right? So when we have plus, they get multiplied. So we have ln x times x plus 1, and here minus means divide, y minus 1. So that is how we could simplify this form, and we get minus 2. Ln is to the base e, and we can now write this in exponential form, right? Now we'll write this in exponential form. So we get x times x plus 1 equals to e to the power of minus 2. Perfect. Divided by y minus 1. Correct? So we can now cross multiply. So we get x times x plus 1 over e to the power of minus 2 equals to y minus 1. Now it is simple. We can say what is y is equal to, right? So we can say y is equal to, taking 1 to this side, and e to the power of minus 2, it could be written in the numerator. So we have this plus e square, which is a constant, times x plus 1. Correct? So that becomes the answer for the given question. Perfect. So these are very typical steps. So to begin with, we applied the rules for logarithms. So that comes as multiplication. This is division. And then we took e to the power, wrote it in exponential form, cross multiply, and solve. Now we'll jump into the next topic, which is even and odd function. Correct? So I hope you remember what is an even function and what is an odd function. Let's give some base for it. We have the even function f of x. If we try to figure out the value of minus of f of x, right? Let me write on the left side. So if I am having f of minus x, and then it could be possible that this is equal to f of x, it could be equal to minus of f of x, or it could be neither. If it is f of x, then we say that the function is even. If it is minus of f of x, we say the function is odd. Otherwise, it's neither. Perfect. That is the whole strategy. So let's see our example and try to simplify. We are given the function f of x as equal to 2 minus 5x whole cube minus 2 plus 5x whole cube. So let's find what is f of minus x equals to. Replacing x with minus x, we get 2 plus 5x whole cube minus, that becomes negative, 2 minus 5x whole cube. Now, how does it correlate to the original one? Well, we have similar kind of structure here. We could take minus common and rewrite this as 2 minus 5x whole cube minus 2 plus 5x whole cube. Perfect. Now that is the function itself. So we could write this as minus f of x. Now since f of minus x is equal to minus of f of x, the function is odd, right? So we have proved that f of minus x is equal to minus of f of x, and therefore the function is odd function. Is that clear to you? So that is how we are going to do even and odd function. So let's take two more examples on this. Now we have one with natural logarithms. Let me rewrite this question. We are given f of x equals to natural log x plus 4 over x minus 4. Let's find what is f of minus x. Replace x with minus x. That is it, right? So what do we get? We get this as written shown here. Now we can take minus common. So if I take minus common, in the numerator we get x minus 4, and in the denominator we get x plus 4. Minus minus cancels, so what we get now is x minus 4 over x plus 4. Correct? That is what we get. But in the given question, what do we have? We have the other way, right? So we can say that f of minus x, let's rewrite, f of minus x is equal to ln. If we flip this, it could be to the power of minus 1. So I could write this as x minus 4 over x plus 4 to the power of minus 1, or it is equals to minus ln x, we flipped it. So it was x plus 4 over x minus 4 to the power of minus 1, correct? So that is how we get this power. So it's minus of ln x plus 4 divided by x minus 4. Now that is the function itself, so we get minus of f of x. So since f of x is minus of f of x, it is also an odd function. Is that clear? Let's take another example, which is a trigonometric function. And here again, the question is of even and odd. So we are given the function f of x as equal to sine x tan x. Now, if I want to write what is f of minus x, I get sine of minus x times tan of minus x. Now sine is an odd function, so we get minus sine x. Perfect. Tan is also an odd function, so we get minus tan x. Minus minus becomes plus, so we get sine x tan x, which is same as f of x. So in this case, we get even function, correct? Why? Since f of minus x is equal to f of x. Is that clear to you? So that is how we are going to deal with even and odd functions. Now it is very important to understand these functions even and odd. Even means what? Even functions are the functions which are symmetric about y-axis, right? So they are symmetric about y-axis. So you can solve one side and get the other side by reflecting it on the y-axis. As far as the odd functions are concerned, they are symmetric about origin, right? So they are symmetric about origin. So these properties really help to understand any function better, right? So we have seen examples of odd and even functions. Now we'll talk about rationalization. So when we do limits, at that time we are going to use rationalization extensively. Now we could rationalize numerator or denominator and at times both, right? So basically to rationalize, we're looking for conjugate. Right? So I will multiply by the conjugate and divide by the conjugate. So the question here is square root of x minus 5 over 25 minus x. Now to rationalize, we could actually write this as square root of x minus 5 over 25 minus x times the conjugate is square root of x plus 5. Correct? Change the sign to get the conjugate. That's it. Now, here we will apply this property. What is a plus b times a minus b? It is equal to a square minus b square. That helps to get rid of the radical sign. So now, when you multiply this, you get a square, which is square root of x square minus 5 square. And in the denominator, we'll write as such, which is 25 minus x times square root of x plus 5. Correct? Don't expand the denominator. But in the numerator, we have x squared minus 25, and denominator also has this term, which is, if I take minus common, I get, x square root, right? Square root x squared is x positive. And here, what we get is minus x minus 25. So I took minus common so that it's easy to explain how and why we are cancelling it. So we can now cancel the numerator with the common factor in the denominator. That gives us the answer as minus of 1 over square root of x plus 5. Correct? That is rationalization. It was a very simple example. Let's take another example now. Slightly complicated. In this case, we are going to rationalize the denominator. So we are given x over square root of x plus 4 minus 2. We could write this as x over square root of x plus 4 minus 2. You can multiply by its conjugate, which is square root of x plus 4 plus 2 divided by square root of x plus 4 plus 2. Now, the numerator can be written as x times, within brackets, square root of x plus 4 plus 2. And in the denominator, we get difference of squares, which is x plus 4 minus 2 square, which is 4. And that could be written as x times, within brackets, square root of x plus 4 plus 2. And in the denominator, we have the number 4 and 4 cancel, so we're left with x. And now you can actually cancel x also. So when you cancel x, what do you get here? You get the result as square root of x plus 4 plus 2, right? So in square root radical functions, or wherever the denominator is involved, it's a good idea to write the restrictions. So clearly, in this particular case, we cannot have x as equal to 0, right? So when you cancel x and x, what do you realize? It means there was a factor, right? 0 in both numerator and denominator. Okay, let's move forward and see the next example. Now, in this particular case, it is important to understand that we need to rationalize, and here we need to rationalize both numerator and denominator. So the question given to us is square root of 3 minus x minus 1 over, we have square root of 6 minus x minus 2. To rationalize, I will multiply by its conjugate, right? So let me rewrite this. Square root of 3 minus x minus 1 over, we have square root of 6 minus x minus 2. So let's rationalize the numerator first. So we get square root of 3 minus x plus 1 over square root of 3 minus x plus 1, right? This part is within square root. And now the denominator, square root of 6 minus x plus 2 over square root of 6 minus x plus 2. That is how we are going to rationalize, correct? Now here we get difference of squares, so we get 3 minus x minus 1, right? So that is one part. This is going to be multiplied by square root of 6 minus x plus 2. In the denominator, difference of squares of 6 minus x will be there. So 6 minus x will become squared, square root will vanish, and we get 2 squared, which is 4, right? So minus 4 times the 3 minus x square root plus 1. Is that clear to you? Now you could simplify. 3 minus x minus 1 is what? 3 minus 1 is 2, right? And so we get 2 minus x in the numerator times square root of 6 minus x plus 2 divided by, in this case, 6 minus 4 is also 2. So again, we get 2 minus x, and here we have within brackets square root of 3 minus x plus 1. We can now cancel the terms 2 minus x and write down the simplified form, right? So you see the advantage in this case. So we have square root 6 minus x plus 2 divided by square root of 3 minus x plus 1. Notice how we have written this, right? So what we get here is kind of important to understand. We get square root of 6 minus x plus 2 over square root of 3 minus x plus 1. Perfect. The factor which cancelled indicates that x should not be equal to 2 in this particular case, right? Now let's take example based on domain and range. We are given the function f of x as equal to 1 over square root of x squared minus 2x minus 3. Now clearly it is a reciprocal function and it will always be positive, right? So in this case, to find the domain, what should we do? To find domain, we know that the denominator cannot be 0. So first thing is that x squared minus 2x minus 3 is not equal to 0. That is first thing. Second thing is that it should be positive, it should be greater than 0, right? Second thing is, let's factor this, that this should also be greater than 0. So we could write it in one term, and that is that this function should be greater than, yeah, we could write like this, greater than 0, because it cannot be 0 and it cannot be negative, right? Let's factor this. So 3 minus 1 can work for us. So x minus 3 times x plus 1, that should be greater than 0. So that is a parabola. You can do with interval notation also, but I'll prefer at this stage to graph and then check the result. So we have a parabola whose x-intercepts are at x equals to 3 and x equals to minus 1, and it opens up, right? So the roots are at minus 1 and 3. Let's say that is the graph. We know that it is positive only during this interval. These points here are minus 1 and 3. So we get our domain and also we'll get our range. Since it is reciprocal of this and a square root type of a function, it is always positive, right? So when you are approaching 0, somewhere here, it could be 1 also, correct? So graph of this particular function will be kind of, let me sketch one here. So will be kind of like this. Um, Let me write down first, show the vertical asymptotes, right? So the zeros will lead to the vertical asymptotes, correct? As you've done in rational functions. And then let's sketch the graph. Positive is positive, and so this, if this is point 1, it is going to be kind of like this, correct? So that is how the graph is going to be. So clearly we can write the domain and the range from the sketch itself, right? So let me write down the domain first. What is the domain? All real numbers except. So from here we have the domain, which is on the left side of minus 1. So minus infinity to minus 1 union. Then we have on the right side of 3. Correct? And as far as the range is concerned, so they belong to real number, of course. Y value is greater than 0. Correct? So y belongs to, we can say y belongs to real numbers and write it in set form. Correct? So we could write it in set form and say x belongs to real numbers. Normally we are putting this on the left side, but it could be placed there also. The next question is domain and range, and this time we have a logarithmic function. So it is f of x equals to ln x square minus 1. And you know x square minus 1 should be greater than 0 for this particular domain. So x square minus 1 is like x plus 1 times x minus 1. That should be greater than 0. We'll apply this sketching strategy which we did in the previous example. It's really helpful. So that's a parabola which is kind of like this. In this case, clearly, we get our domain as towards the left side or towards the right side of these values, which are plus and minus 1, correct? So that becomes the domain. As far as the range of the function is concerned, logarithmic functions have no restrictions. For the value which is less than 1, the logarithmic function will be negative. So as far as the domain and range is concerned, we know that the domain of this particular function is x belongs to real numbers, but x is less than, or you can say either side, correct? So we can say as x is less than minus 1 or x is greater than plus 1, correct? So you could also write this domain as, sometimes we'll write this as absolute value of x is greater than 1, right? So that could be another way of writing this, where x belongs to real numbers. That could be written like this. Perfect. So as far as the logarithmic functions are concerned, range has no restriction. So we get y belongs to real numbers. Clear? So that is how we are going to write the domain and range of the given function. Now, let's see the next example, which is sketch the function and write down the range. We are given the function f of x as equal to 1 minus square root of 6 minus 3x. This is the last question. I would like you to pause the video, answer, and then look into my suggestion. I always prefer to write it in standard way. So, which is factor out this 3, right? So leading coefficient should always be factored. So we are left with x minus 3 has been factored. So we get x minus 2 within the brackets, everything under square root, plus 1. So that becomes your function. Now let us see how to sketch this particular function, and then we are going to write down the domain and range. So let's begin with the square root function, right? So this is our square root function. Let us say square root of x. Now to this square root function, these are the transformations applied. So here the first one is reflection on x-axis. And then we have reflection on y-axis, right? And then we have translate 2 units right and 1 unit up. So those are the transformations. So now we already have the function square root x. We can now reflect this on both the x's. So you could perform it like this. So that is on the y-axis, which we did. And now we could do, let's use another ring. Let's do like this. So that is on the x-axis, which we reflected, correct? After this reflection, we have to change the position. We have to change the position from 0. It moves to 2 units right and 1 up. So kind of, let's say 2 units right, 1 up will give you a graph, which is this final graph, correct? So that becomes the function for us, where this point here is 2 right and 1 up. So now we can write down the domain and range, correct? So the domain can be written as x belongs to real number, where x is less than equal to, right, the x value of 2. The range will be y belongs to real number, where y is less than and equal to the tip, which is at the y value of 1, correct? So that is how we are going to write domain and range. So clearly this value of 1 is associated with y value of 1, and once you factor, in that case we know the other value is associated with the domain. So that is how we are going to answer all these questions. So I hope with this you understand how we could isolate variables, how we could write an equation in explicit form, how do we find whether a function is even or odd, how to write domain and range, and also sketch a function, then write domain and range. I hope that helps. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.